AET 114, Chapter 17, Series Parallel AC Networks. So basically, we're combining both the series and parallel properties of AC networks that we learned in Chapters 15 and 16. So it can be boiled down to dealing with the ladder network. You have an input voltage right here, and then you have a bunch of impedances right here in various combinations. Um, In this example, you're looking for I6, which is the current through impedance Z6, which is also the same current that's going through Z5. It's going through this part of the loop. So the first part of the procedure is calculate the total impedance of the circuit from individual impedances. You, you treat impedances just like resistors. They can be dealt with in series or parallel in the same manner. Easier to add, subtract impedance in rectangular R plus JX form, where R is the resistive component and X is the reactive component. Multiply and divide in polar Z angle of theta form. And then use Ohm's law, voltage divider, KCL, KVL, and or current divider to find unknown values. Okay, so I added some clarification to this figure as defined by how the book defined so the different impedances. What you have to do is do the reduce and return approach, which we learned back in DC analysis. So you start over here on the right side of the ladder and you start reducing back to the left. These the definition of these impedances are arbitrary. The book likes to use primes, like this is Z double prime T, Z prime T, and then total impedance ZT. And I put these lines in here to show you like where they start, and they're looking this to the right. Um, Again, it's arbitrary how far you break this down. The further you break it down, the simpler it is. The book did it in 3 steps, but you could do it in more than 3. You don't have to do it exactly like the book did it. So to start from the right here, Z double prime T is going to be Z5 plus Z6 because they're in series, okay? They're only connected on one end. So I redrew that step right here, showing you what Z double prime then looks like in the circuit. It's Z5 plus Z6, and it has current I6 going through it, through this leg right here. All right, so that's step 1, and they defined that right here also. So then the next step is to take Z double prime is obviously in parallel with Z4 because they're connected on both ends. So you put those two in parallel, and then you can add them. You can add them to Z3 because they're in series with Z. When you take these two together and make them as one resistance or one impedance, then that is in series with Z3. So they kind of did 2 steps in the book, and they defined Z prime T as Z4 in parallel with ZT added to Z3. Okay, that this is one impedance, and then added to Z3 makes ZT prime. So you can see how they did that here. And then the next step was they again did 2 steps in 1 step. Z2 and ZT prime are in parallel. So they did that. They did that step with these two in parallel, and then you add. Oh, this is a mistake. It's supposed to be adding Z3, or I'm sorry. So this is correct here. And then the next step that they did was they took Z2 and ZT prime in parallel and added Z1 to it to get the total impedance. So this is how they did this right here. I'm just breaking it down so you can see how they did it. And then what you do is you find I by using Ohm's law, E divided by ZT. And then you use the current divider. Okay, you're going backwards now. We're going to go back up the page so you know what I is. And then I comes into this junction right here. It goes down through Z2, which would be I2. I would call it I2. And then I3 goes through ZT like that through this leg. So use the current divider like that. So I3 would be equal to Z2 times I, which is the source current coming in, divided by Z2 plus ZT prime. And then you do the current divider a second time up here. So you have I3 coming into this junction, and then you have Z4, you would have I4 going through Z4, and I6 going through ZT double prime. So I6 would be Z4 times I3, because you in the numerator it's always the opposite. If you're looking for the current leg, the current through this leg, then you use this impedance in the numerator, and then you divide by the sum of the two impedances. So that's how you find I6, and that was what you were looking for in the original problem. And then what you can do once you have that is you can calculate the power through delivered to this resistor, and which is usually something that's going to be asked for, because it takes all these steps to get and find out what I6 is, and then you can do that calculation. So this is really the entire chapter summed up in one problem, which is how to do this. Of course, all these impedances are going to be phasors, and again, you follow this instruction here on how to add, subtract. Whenever you add, subtract, you want to do it in rectangular, multiply and divide in polar, and obviously you're going to be using a calculator that can do complex numbers. So you're going to want to use that, and it shouldn't care which form it's in. You should be able to do these calculations, but when you do this kind of problem, I would expect you to, be showing this work, drawing the circuit like this, and then keep drawing it to show that you're understanding to break it down. And then you're going to go backwards to find the currents. And that's really it for chapter 17. Again, the more work you show when you do a problem, the easier it is for you to understand and for me to understand to be able to grade. So I highly recommend redrawing circuits like this and showing your work, defining, you can break it down even further. Like you could have broke down the impedance here and then broke it down here, which would have been Z4 in parallel with ZT prime, double prime, I mean, and then here, and then again here, and then here. So you could have did a couple more steps in between, but that's basically how to do it.